I stop the recording? That's bizarre. Okay. Hopefully that's all in there. 4 is y. So if we go back in here, this equation, the intercept form, and we plug in what x, y of a point is and our m value, we can figure out what our y-intercept is. Once we know what b is and we know what m is, we're given that, we know the equation of a line. And so that's how I tend to do these, and I don't use the other formula, but do whatever you feel you like best. So 4 is equal to m, which is negative 3/4, all times x, which we see is 2, plus b. So 4 is equal to negative 3/4 times 2 plus b. So I notice that I have a 2 in the numerator, 4 in the denominator. That simplifies just a little bit. I want to isolate my b value. So right now we have 4 is equal to negative 3/2 plus b. I can clear my fraction, or I could just add 3/2 to both sides. I'm just going to add 3/2 to both sides. But I also notice that I don't have a common denominator. So while I'm doing that, I'm going to get a common denominator. And I notice my common denominator is 2. So I have 2/2 times 4 is 8/2. I'm adding 3/2 to both sides to isolate b. So plus 3/2 equals b. So I can see that b is equal to 11/2. So knowing what b is, knowing what m is, let's just go back and plug what those in. All right. And so we get y is equal to m, which is negative 3/4, times x plus b. And b is, we just found to be 11/2. So that's in our slope-intercept form. If they asked and they said, we want the answer in standard form, if we want that, we want to clear the fractions. So because it's an equation, we can clear the fraction by multiplying by that least common denominator. The least common denominator, 4 and 2 is 4. So if we multiplied everything through by 4, we would get 4y is equal to negative 3x plus, because 4's cancel, 2 goes into 4 twice, 22. And so get the terms with x on one side, or get all the variables to one side. So if we add 3x to both sides, we get 3x plus 4y is equal to 22. This is kind of just a review. You guys should know that parallel lines, well, if they're parallel, they're rising and falling or and running at the same rate, right? So if that's the case, then we know that the slopes have to be the same. Perpendicular lines. So that is where you have two lines that intersect, and if they're intersecting one another, they're intersecting at one another at a 90-degree angle. So 90-degree angle intersection. So if M, let's say M equals A over B is the slope of one line, then the perpendicular line is negative B over A. I'm not sure how to denote, I mean, I kind of do it like this. I don't know if you, back in geometry, I remember the symbol, the upside down capital T meant perpendicular. So I just kind of denote it that this is my perpendicular. But basically, if I flip negative B over A and take the opposite side, I would get A over B. So they're perpendicular of one another if that's the case. A couple other things that you should know. If you have a horizontal line, but to get from one point to another, any point I choose on here, notice I'm not rising anything. So if I'm not rising to get to a point, I have 0 in my numerator. And I could be running any distance and get a point on here. So notice that 0 over a number is 0. And so horizontal lines, slopes are 0. The equation of horizontal lines, well, if x is 0, if your slope is 0, right, you get y equals mx plus b. Let's plug in 0 for that equation. We would get y is equal to 0 times x plus b. So y is equal to b. My y's are kind of funky over here. I don't like them. So horizontal lines are always in the form of y equals a constant. So if y is equal to some number and there's no x in there, you know it's a horizontal line. So vertical lines, if your line is vertical, actually horizontal lines are something that you'll be looking for all the time when you get into calculus. So basically, you're going to be graphing things and you're going to be looking at equations of tangent lines. You're going to be able to find slopes on anything. And notice if I write a line here, right here, these slopes of these lines on max and mins are 0. And you'll be finding equations of lines a lot in calculus. So you need to get good at that. So if you don't remember that, you might want to do a little more extensive review than what I'm covering today. But vertical lines, if we look at a vertical line and we think about direction, think about the slope, well, I'm not running anything, I'm just rising or falling. And so if we're thinking about the slope rise over run, well, I'm rising some number, but I'm not running over 0, and so that's 0. And this is undefined. So basically, if it's a vertical line, your slope is undefined. Vertical lines are always going to be in the form of x equals some number, let's say c. So if you look at an equation and you don't see any value of y in there, then you know it's a vertical line going through that number. So if it says find a parallel line that's parallel to the line 2x minus y equals -2, and it contains the point 0, 0. So always, 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 to find an equation of a line, you need 2 things. And if you're not given those 2 things, you can find those 2 things with the information you're given. To find an equation of a line, you need a point, 1 point. If you have more than 1 point, that's great. And you need to know what the slope of the line is. And so if you're not given those 2 things, then you have to look at what you're given and you'll be able to find it. Well, I see I'm given a 0.00, but notice I'm not given a slope. So how are we going to find the slope with the information given? Here, this is the time I want to answer my own question. Maybe you guys know this one. Well, there was different forms of lines, and there was one form of a line that actually we could look at and identify what the slope of the equation is. I'm answering my own question. So we need to find the slope of the following line. And we want to find the slope of this line because we know the slope of parallel lines are have the same slope. So we need to find the slope of this line. And so we can always do that if we're given the equation by putting it in the form, and it's linear, put in the form y equals mx plus b. So get y by itself, subtract 2x on both sides, so we're left with -y is equal to, subtracting 2x, -2x minus 2, not like terms. We want it positive y, so multiply through by -1 on each side. We get y is equal to positive 2x plus 2. So this is in the form of y equals mx plus b. So our slope is 2. And so our parallel line, the slope is also 2. They're equal to. Okay, so we know a point and we know the slope. And so you can use your point slope formula, or again, if you plug in your x value and your y value of your point and your slope, we can figure out what we have. So y is 0 is equal to our slope 2 times x, which is 0, plus b. So b would have to be 0. So if b is 0, our slope is 2. We're not quite done. We want the equation of the line. The equation of the line is y is equal to our slope 2 times x plus b. Well, plus 0 is 0. So we just have the equation of line parallel to a line going through a particular point. Okay, so I don't want to spend too much more time on this unless you guys are struggling. Let me pause this. Okay, so we're looking at circles. And if we have a circle in a certain form, then we can tell what the center of the circle is and what the radius of the circle is. And so a standard form of a circle can be written as parentheses x minus h into parentheses quantity squared plus parentheses y minus k into parentheses quantity squared equals r squared. And so when it's in this form, the point hk, this is equal to the center of the circle, and r is equal to the radius. So a couple things just to notice about that is it's the opposite sign. So it's x minus h. It's the opposite sign that you see in there is what the x value is. Same thing with the k value, minus k. It's the opposite sign. So if you had seen y plus 2, opposite sign, that y value of the center would have been negative 2. And then the other thing is it's set equal to the radius squared. So once we get it in this form, if we take the square root of what it would equal to, that would give us what the radius is. So another thing that you should just realize is if you don't have that quantity squared of x or y with an addition or subtraction of some number, so let's say we have x squared plus y squared, this is the case where both of those don't, equals r squared, this is centered at 0, 0. So basically our h value is 0 and our k value is 0. What else? So for example, let's say that you were given that r is equal to the square root of 13 and the center hk is equal to 5, negative 1. So given information about a circle, you should be able to find the equation. So if it's labeled that differently, that the center was 5, negative 1, we know that that point hk is also considered 5 and negative 1. So we're going to go through here and plug in what we know. Well, we have x minus whatever that h value is. We'll come back. Quantity squared plus y minus whatever that k value is, I'll come back in a second, squared equals whatever r is squared. So h is 5. So it's x minus 5. My k value here is -1. So it's minus a -1. And my r value, my radius I'm given is square root of 13. So I can clean it up a little bit. So I'm given this is x minus 5 quantity squared plus y minus a negative, so that's really plus. Y plus 1 quantity squared is equal to the square root of 13 quantity squared is just 13. So let's say you were given 3 all times the quantity, x plus 1 quantity squared, plus 3 all times the quantity, y minus 1 quantity squared is equal to 6. So it's not quite in standard form. So let's first put it in standard form. So that standard form, if we look back there, notice that there's no coefficient, well, coefficient of 1, other than that 1 that is in front of those quantity squares. And in our equation that we're looking at now, in our example, we have a 3 in front of both the quantity squares. And so it's almost in standard form. We just need to get rid of those 3's in front of x plus 1 quantity squared and y minus 1 quantity squared. And we can do that by dividing. This is an equation, so we can do this. So whatever we do to one side, we can do to the other. So if we divide everything through by 3, it's now in standard form. So we have x plus 1 quantity squared plus y minus 1 quantity squared is equal to 2. So find the center and radius. So it's opposite sign, our h value. So this is going to be -1. Opposite sign of -1, so +1. So our center is at the point -1, 1. And the radius, well, we're given that r squared is equal to 2. So r is equal to √2. So when we take the square root of both sides there, we don't worry about the negative because we're talking about distance. Radius is a distance. Okay. You should be able to, we could graph this without finding the x and the y-intercepts, but you should be able to find x and y-intercepts. And I believe some of the homework asks you to do that. So recall x-intercept, we let the y value equal 0 and solve for x. So if we go back into our equation, we have x plus 1 quantity squared plus, well, I see a y here, I'm going to replace it with 0. So I'm going to just put a parentheses there. Minus 1 quantity squared equals 2. So I need to solve for x. So this is where chapter 1 could be really helpful for us. Look at this. We have a perfect square here, x plus 1 quantity squared. We have a -1 quantity squared, which is plus 1 equals 2. So multiple ways we can go about solving this. I notice it's quadratic. We could FOIL out and distribute out x plus 1 times x plus 1, get everything to one side. Hopefully it factors, if not quadratic formula. Or you should notice there's a perfect square in here. And then the rest of the terms outside, it doesn't have any of the variable. So we could isolate our perfect square and use our square root method. So that would be a lot faster than what I had mentioned before. So let's do that. Let's isolate our perfect square. So subtract 1 on both sides. We get x plus 1. Quantity squared equals 2 minus 1 is 1. Apply the square root method. So the square root of both sides. Put the plus or minus in front of, I usually do it the constant. It's easier. And so we get x plus 1, square root and square cancels, equal to plus or minus 1. So we have two separate values that we're going to get for x. So we're looking at when is x plus 1 equals positive 1 and x plus 1 is equal to negative 1. So subtract 1 on both sides, I get x is 0. Subtract both 1 on both sides of the other equation, we get x is negative 2. So you'll notice that once your circle is in standard form, and right now we've only dealt with it in standard form, if it's not in standard form, putting it in standard form could be helpful for finding x and y-intercepts. You'll be able to use this square root method every time, because if you noticed back in the standard form, you had an x quantity squared and a y quantity squared. So for finding the y-intercept, where we let x equals 0, so we're going back in our original equation, and so our original equation was x plus 1, but we're replacing x with 0. Quantity squared plus parentheses y minus 1, quantity squared equals 2. So solving for y now, so we have 1 quantity squared is 1, plus y minus 1 quantity squared equals 2. So it's in the form that, again, we can use the square root method. Isolate the square, subtract 1 on both sides. We would have the equation y minus 1 quantity squared equals 1. Take the square root of both sides. You get y minus 1 equals square root of 1 is 1, so plus or minus 1. So you have two separate equations. You might be able to just see it without writing them out, but you have y minus 1 equals 1 and y minus 1 equals negative 1. Add 1 to both sides to get y by itself. First equation, you get 2. Second equation, you get 0. So one more piece for this example is to graph it. So really, again, we don't really need to know our x and our y-intercepts to help us graph it. If we know the center and we know what the radius is, basically from that center, you could always just go up your radius, down your radius, left and right. My other left and right. I'm not sure how it's coming from you guys. Anyways, so let's graph it. And this is step D. So again, we saw that our center was equal to -1 and 1. And our radius, we said, was √2. That's where it might be a little bit harder to graph, but you can estimate that. If you plug in square root of 2 into your calculator, well, you should know that it's falling in between 1 and 2, because the integers that sandwich 2 that are perfect squares are 1 and 4. Square root of 1 is 1, square root of 4 is 2, so it has to be in between there. You can just kind of estimate. But we found some really nice points. We found that when y is 0 is a point, y is 2 is a point. We also found our x-intercepts, which was 0 and -2. And we said that our center was at -1, 1. And this is approximately, I believe, 1.4 if you plug that in the calculator. So if we go about 1.4 from this, would get me about here. If I go down 1.4 from here, if I go to the right 1.4 and to the left 1.4. And connect my points. It's not great. It's hard to make circles. But you guys can, I bet you have a good imagination. You can imagine it. There we go. Okay, but they're not normally in standard form when you get them, and so you're going to need to put them in standard form. So in our standard form, notice again, you have a quantity perfect square plus a perfect square. We talked about earlier in chapter 1 how to complete the square. And so you're going to do that a lot, completing the square, especially when we get into conic sections. So circles are conic, or as a conic, ellipses, hyperbolas, parabolas that face in different directions. And that is something that we'll look at more at the end of the semester. Okay. So let's look at the following. How about x squared plus y squared plus 4x plus 2y minus 20 is equal to 0. Okay, so I'll remind you about this in a few weeks, but I can tell that this is a circle because I have an x squared term in here and a y squared term in here. I can also tell that it's a circle because the number in front of my x squared term and my y squared term is the exact same number. And so when we're doing these examples, you'll see that they're the exact same numbers. If they were different numbers, that actually clues me in. It's either a hyperbola or an ellipse. First thing what we want to do is we want to group our x and our y terms together so that we can complete the square both on the x terms and the y terms. So put this in standard form. So group terms. With x's together, y's together, and move the constant to the other side. And sometimes it's already on the other side, so let's say move the constant to be by itself, to be isolated. Okay, so we just want to rewrite this And when we rewrite it by grouping our x and our y terms together, we're going to leave a little space. So I have an x squared. I have another term that has an x. It's positive. So plus 4x. I'm going to leave a space here because we are going to add something here on this side of the equation that's going to make this a perfect square. We'll come back to that in a second. So now I'm grouping my y terms together. So I have a plus y squared. This is a positive 2y, so plus 2y. Again, in order to make this a perfect square, I'm going to have to add something here. And so let's just put plus something with a line. This is equal to, so to get that constant to the other side of the equation, this is minus 20, so we'd have to add 20 to both sides. Oops. So adding 20 to both sides, we get 20. The thing is, when I left that spot and I said, well, we have to add something here, let's leave it. Come on. Right here, if I added something to this side, because it's an equation and I can only do that, I have to add it to the other side to remain equivalent. So same sort of idea, when I add this number, whatever we figure it out to be, here I have to add the number on the other side of the equation. Okay, so recall, we were looking for pleating the square. It was the same number you would add to get that middle term. And one, first of all, coefficient from the square had to be 1, which we already have, so we're good. So to complete the square after that, coefficient is 1. You look at what number can you add to itself to get the middle term b. That number you would add to get itself, you're going to multiply by itself. So trick is just half it, because that would give you the same number you would add to itself. So half of 4 is 2. And so this number, in order to make it a perfect square, use that number we found, 2, and multiply it by itself. So 2 times 2 is 4. So we're going to add 4 to our x terms to make it a perfect square. But that means I have to add 4 on the other side of the equation. Okay, so same idea. You're looking for the same number that would add to give you 2 for our y terms. Well, half it. Half of 2 is 1. And so that same number, multiply it by itself. 1 times 1 is 1. So 1 is the number we need to add to both sides to make that a perfect square. Okay, so we just manipulated this to give us what we wanted. So we can now rewrite the first 3 terms as a perfect square plus the last 3 terms as a perfect square. So the same number that we add to get it 4 and multiply to get 4 is 2. So we could factor this as x plus 2 quantity squared. The same number we multiply to give us 1 and add to give us 2 is 1. So this is y plus 1 quantity squared. Is equal to 20 plus 4 is 24 plus 1 is 25. So maybe I can add this in here, number 2, complete square. On x and y terms. Okay, so from there you should be able to graph it. You should be able to identify, so in order to graph you have to identify the center and you should be able to identify what the radius is. So really quick, h opposite sign, so this is going to be minus 2 or negative 2. Y plus 1, so opposite sign, so this is going to be negative 1. So my center is at negative 2, negative 1. Our radius squared is 25. So that means my radius is 5. I should be able to graph it. So if we go to the left 2, down 1, we get our center. Let me just make some more points. Okay. Okay, so again, up, down, left, right, the radius from the center. So if we go up from -1, so going up, so adding 5 to -1 gets my y value at 4. So I have a point at -2, 4. So that's a point on my circle. If I go to the right 5 from -2, my x value, adding 5 to -2 gives me +3. So I know I have a point, my y value is going to stay the same. I have a point at 3, -1 is on the circle. So go down 5 from -1, so -5 minus 5, I would get -6. So my point would be -2, -6. Go to the left from -2, so -2 minus 5, I get a point at -7, -1. And then draw your circle if you can. Okay. It's not the best, but you get the gist. Okay, let's try one more. And then we're doing good. We might be able to do this and get through this chapter. So 2x squared, let's look at plus 2y squared plus 8x plus 7 is equal to 0. So here's a case where our coefficient in front of the x squared and the y squared isn't 1. And so we're going to have a problem when we complete the square. So we're going to have to make that a 1. The nice thing about circles, again, is that that number in front of the x squared and the y squared are always going to be the same number. And because they're the same number, we can always just divide every term through by that number. Because this, again, is an equation. So we can do that and make it equivalent. Once we get into ellipses and hyperbolas and parabolas, we're not going to be able to do that because they're not going to be the same number. Parabola is different. Anyways, so divide everything through by 2 and let's regroup this so all our x terms are together and all the y terms are together. So doing that, we have x squared. Over here, my other x term, we have an 8x divided by 2, so there's plus 4x. We're going to add something in here in a minute to make this a perfect square, so I'm going to just leave some room. I'm going to add it on the other side of my equal sign in a minute too. Let's group our y terms together after reducing. And so I have 2y squared divided by 2. That's y squared. But I notice there's no other term in here that has a y. So I'm good there. And I need to move the constant to the other side. So if I move the constant to the other side, I'm subtracting 7/2 on both sides. And because there was no other y term in there, I don't have to worry about making that a perfect square. It's already a perfect square. So you're looking at the number in front of your x term. You're dividing that by 2 to figure out what number you're going to add. So 4 divided by 2 is 2. Take that number, multiply it by itself. 2 times 2 is 4. So we're going to add 4 to both sides of our equation. So we can now rewrite those first 3 terms as a perfect square. So the same number we multiply to give us 4 and add to give us 4 is 2. So x plus 2 quantity squared is our factor. Should we have a plus? Plus y squared. If it helps you, you could put minus 0 here to see that that k value is 0. You don't have to. Is equal to, well, we need a common denominator. So I need to multiply this 4 by 2 over 2. So that's actually 8 halves minus 7 halves. That gives us 1 half. So our center is at opposite sign. So negative 2, and our y value is 0. We have to do a little work on the radius. R squared is 1/2. When we take the square root of both sides and we're only worried about the positive, we have the square root of the fraction. Rule says if you have a square root of a fraction, it's the same as the square root of the numerator. So square root of 1 all over the square root of 2. We want to not have, normally we don't like radicals in the denominator. And so we're going to have to rationalize our denominator. So I have square root of 1 is just 1, squared over square root of 2. So I'm trying to multiply this by a fancy 1 so that I can get rid of that radical. And I know square root of 4 would get rid of that, that's just 2. So I can multiply both the numerator and denominator by square root of 2. So this gives us root 2 over square root of 2 times square root of 2 is 2. Okay, if I was to graph that, and I'm not going to spend time graphing that, I'd have to go into my calculator or do a little bit of math and reasoning to approximate what that is, to be able to kind of identify how far I'm going to go up and down, left and right from my center. See how my math lab wants it. My guess is they're going to want it kept like that, and my guess is they're going to want you to rationalize the denominator. If not, and if you're taking my trig class, we were rationalizing denominators a lot, so hopefully that was really simple for you. Okay, moving right along. One more section, and this last section is on variation. So variation problems are word problems. They're actually some of the, I think, the simplest word problems in the way that if you have the form that they want you to write things in, it's really simple. They always are going to say things in a certain way that you can set up the equation pretty easily. I want to get a new page. And this is another topic that we do cover in college, not college algebra, intermediate algebra. So again, this hopefully is a review. So there's variation problems. So there's different wording, and you might see the following. If you see the following and it says y varies directly with x. So to set up these problems, if you see a variable and then it says varies, you're going to take that variable and you're going to put an equal sign. these problems always have this constant in here. And it's varying by this constant. And we want to figure out what that constant is. And usually we'll see it as K in these types of problems. So in these problems, K is equal to some constant for our word problem. Something that doesn't change with the information that changes. So directly with X means that you're just taking that constant and multiplying it by that variable, in this case, X. So for instance, if it says Y varies directly with the square root of X and Z cubed. So first thing when I'm writing these problems, and these are kind of not like an application yet, I would write out this general equation that this is telling me. And so again, I have Y varies directly. So Y equals, I'm always putting in that constant K. Part of our thing is to be able to figure out what that K has to be for our problem. Varies directly means multiplication. So, but it's telling me with the square root of X. So I'm going to write it with the square root of X and the Z cubed. So I'm actually then multiplying the square root of X times Z cubed. So you'll notice my Z's have that bar in between, and that's just so you can distinguish more between my 2's and my Z's. The other thing, a lot of times I make my X's kind of curly because of multiplication sign, but usually we don't use X for multiplication in upper courses. So varies directly. Or sometimes you might see instead of directly, it's a proportionally. I tend to like the directly better. The other one is Y varies inversely. That is not the same thing. Sorry, I got caught up with that. I'll come back to that in a second. Y varies inversely with X. So this means Y is equal to K, our constant. Inversely, unfortunately, this actually is, I don't think is a great term, but that means you put X in the denominator. Another way they could have stated this is Y is, how do they say it? I never do it this way, is inversely proportional. This Y varies directly. The other way to say this was directly proportional. One more. and that's jointly, and then we can quickly go through some problems that will explain this, and it will show you how easy, when you're reading through the problems, they go and how smoothly they go. So the other one is jointly. They didn't write it out. So if it says y varies jointly with x, or the other way with the proportionally would be y is jointly proportional with x. So jointly means it's just multiplication. You have more than one variable. So that other example up there, I could have said very directly with the square root of x and joint, and I don't know how I would have said that. Okay, so y is equal to k, always in there, our constant, jointly proportional with x, and I didn't finish. I need it jointly with something else. And so let's say and z. And z. So it would be x times z. Okay. Here's the laydown again. So you're going to read through your word problem. You're going to come up with your generic equation that we just did with the variables. And then your word problem is going to give you enough information so that you can plug in numbers for all those variables except for k. And so we could figure out what k is. Once we know what k is, we can answer any question they throw at us that pertains to that example. And so let's look at the following, and it says, z varies directly with the sum of the cube of x and the square of y. So write a general formula to describe the variation. And they give us, well, let's first describe that, and then they give us some numbers. Okay, so z varies directly. So right there, that tells me that z is equal to, again, I always have my constant k, times, what's what is it asking? Let's see, or where is it at? So directly, that means multiplication. But it's with the sum of the cube of x and the square of y. So I know I'm summing these terms. The cube of x is x cubed, sum, so plus square of y, so y squared. So let's find k given that z is equal to 1 when x is equal to 2 and y is equal to 3. So they're going to give us enough information. They just spelled it out to us. We're just going to plug in those numbers for z, x, and y, we'll have just k left in there and we can solve for k. So we have z is our 1. So we have 1 is equal to k all times x is 2, so 2 cubed, plus y is 3, so 3 cubed. So we have 1 is equal to order of operation.
3 squared, right?
Yes, thank you, 3 squared. 3 squared. And I'm starting to try to pick up pace, and so I'm going to start making errors, so I should stop that. So 2 cubed is 8, plus 3 squared is 9. So summing that, we get 8 plus 9 is 17. So we get 1 is equal to k times 17. Divide by 17 on both sides, I get k is equal to 1 over 17. So we're not quite done. Once you find what k is, we have to plug it back into this equation. And then we have the generic equation that would help us answer anything else. So z is equal to k, which is 1 over 17, all times x cubed plus y squared. Let's pause for a second. Okay, so let's pull out an actual application. And I'm just coming up with this. This one looks good, a cost equation. So the cost C of roasted almonds varies directly with the number of A pounds of almonds purchased. Okay, so remember we talked about, we're going to read through this and then we're going to come back and we're going to nitpick this and pull out what we want. If it costs $23.75 when the number of pounds of roasted almond purchased is 5, find the linear equation that relates the cost C to the number A of pounds of almonds purchased. Then find the cost C when the number of pounds of almonds purchased is 3.5. Okay, so again, a lot going on there. And I told you these weren't bad. So, and maybe I need to write this out so you guys can see it. So it says the cost C of almonds, roasted almonds, then I'm just going to put almonds, varies directly with a number of A of pounds purchased that's it. Okay, well, it basically told us, and it told us what variables to use. The cost C of almonds varies directly. So I know then C equals, because it says it's varying directly. And so I'm going to put my K in here. K directly with the number of A of pounds purchased. So I know that I have my value of A in here. So times A. Okay, so I'm going to go back, continue reading, and then, because we have our generic equation, so that I can figure out what K is. So it then said if the cost is $23.75 when the number of almonds purchased is 5. So when 5 pounds is purchased. So I would actually stop there before I write any more, and I would go back in and I would say, okay, I can figure out what K is now. So let's figure out what K is with that information. So we know what the cost is. We know the cost was $23.75. So we have $23.75 is equal to our K value times, and then it told me the amount of almonds that was purchased. The amount of almonds that was purchased was 5 pounds. So I notice I can get K by itself by dividing both sides by 5. So if I take $23.75 and divide that by 5, we get back $4.75. And so we basically now have the cost of any roasted almond. And it is C is equal to 4.75 A. And so now the next part of the question we can answer, and we could have answered anything they said or asked us. And it says, then find the cost C when the number of pounds of almonds is 3.5 pounds.
Did you say 3.5 pounds?
Yeah, so 3.5 pounds purchased. So if we're trying to find that cost, well, that's just C equals, well, that 475, that's just relating, actually it's talking about the cost per pound, right? So 475 times our 3.5 pounds. So our cost is gonna be $16. And so this gives me 0.625, but it doesn't make sense in terms of cents. So that 5 is going to round that 2 to a 3, so 63 cents. Now I'm going to change that to approximate sign because I approximated in there. Okay, one more. Okay, safety. Safe load for a beam. So some of you might be wanting to be engineers out there, architecture engineers. We want you guys to know your math. Okay, so the maximum safe load for a horizontal rectangular beam varies directly with the width of the beam and the square of the thickness of the beam, and inversely with its length. If an 8-foot beam with a support of 750 pounds, when the beam is 4 inches wide and 2 inches thick, what is the maximum safe load in a similar beam with 10 feet long, 6 inches wide, and 2 inches thick? So again, a lot of information and kind of overload, sensory overload, but this is not too bad. So we're going to read through it and we're going to pull out our generic equation. So it says the maximum safe load for a horizontal rectangular beam varies directly. Unfortunately, they don't give us variables. So maximum load a beam can hold. So maybe we can say M for maximum, so M. And I see that this varies directly with So varies directly with the width of the beam. So let's call that W. So K times W. And the square of the thickness of the beam. Thickness, well, maybe T. So with a square of the thickness, T squared. And inversely with a length. And inversely with a length. So we can call the length L. Oops, and it's inversely. So that tells me that we're dividing by L. Okay, so we kind of nitpicked so we can get that general equation. And now they're going to start throwing numbers at us so that we can figure out what K is. And so it says if an 8-foot beam will support 750 pounds when the beam is 4 inches wide and 2 inches thick. So now you're going to read what the question asks from that. So we can figure out what those variables are representing and plug this back in. And so we have an 8-foot beam. We have the thickness and the width. So the length of our beam looks like it's 8 feet. It's 4 feet wide. So this is our W. Here, 2 inches thick, that is our T. This 8 is our length. And the 750 is our maximum M. And so if we go back in there and plug those values in, we got 750 is equal to K times the width, which was 4, times the thickness, which is 2. We're going to square that, all over the length, which is 8. So we have 750 is equal to, well, things can cancel. I have a 8 in the numerator and a 4 in the denominator. I'm sorry, an 8 in the denominator, 4 in the numerator. 4 goes into 8 twice. 4 goes into itself once. Well, 2 squared over 2, well, that would cancel this with that 2. So that would give me...
Wait, shouldn't you change the feet to match the inches?
I don't think we have to. That's a good question, though. As long as what we're given next when we're asked to find the information is the same. So as long as our thickness is still is in inches, our feet is in inches, and our length is in a foot, we're good. But if they're not the same units, then we do need to worry about units. Okay, so that would have left me with just a 2K, and thank you for stopping me because I'd rather do that before I finish and then have to go back and do it. So K is 350. So we now have our generic equation that we can now answer what they are throwing at us. So we have our maximum load is equal to 350. Oops, that's not right. 2 goes into 750. 375 times. So we have M is equal to 375 W T squared over O. And so now they're asking us, what is the maximum safe load in a similar beam that is 10 feet long (6 inches wide and 2 inches thick. And so our length and our is in feet like our original when we found K, and our width and our thickness is also in inches like our original problem when we found K, so we're okay. So we can find the maximum load is equal to 375 times our width. Our width is 6, so 6 times our thickness. This is our T value, so 2 squared, all over the length, which was 10. So 375 times 6 times 4, all over 10. Some of this reduces. 2 goes into there 5 times, 2 goes in there 3 times, 5 goes in here 75 times. 75 times 3 is 225. 225 times 4. I think is 1,000. Did I do that right?
I plugged it in the calculator and got 900.
I was hoping I could do that without the calculator. Okay. Somewhere I went wrong. 375. Oh well. And I was trying to go fast too. Okay, let me just erase that. And this is equal to 900 pounds. Okay. And that is the correct answer, is 900. And when you plug that in, those were the numbers we set it up with, right? Okay. We did it. We did it. You guys are awesome. You made it through 1 week of summer school. We have 5 more weeks to go. Hopefully you were able to get into homework and do that. I was mentioning to Trig class that I might meet up with you guys tomorrow to hold a session, but then I was thinking that maybe instead of doing that, so go get help with tutors. There's lots of tutors out there, and they don't want to sit there. They want help to help you guys. But go get help. If you are struggling and you went to go see a tutor, why don't you email me which problem you're struggling with? But you're going to have to do that by this evening. And I was thinking I would come and make a video of doing a couple of homework questions and posting that for you guys. Does that sound good? I guess I can stop recording.